Why Gemma 4 for Edge? Segment 1. The decision space. Choosing an LLM for production is a real decision. 3 categories of options exist today, each with different trade-offs. Understanding the landscape comes first. Category 1. Cloud APIs, GPT, Claude, Gemini, the most capable LLMs available. Hosted by someone else, you pay per token, your data leaves your network. Category 2. Proprietary models you license and run on your hardware. Capable but bound by vendor licensing. You own the deployment, not the model weights. Category 3. Open weights models. Gemma, Llama, Mistral, Qwen. You download the weights, you run them, you own the deployment and the model itself. Each category trades something: capability for control, cost for convenience, privacy for raw power. There is no universally right answer. The right choice depends on your use case. For one real use case, a home lab AI agent, the answer turned out to be open weights. 3 categories, 3 sets of trade-offs. The right answer depends on the job. Open weights models are different from APIs and licensed software. You download the weights, you own them, you ship them. Let's see why that matters. Proprietary models lock their weights behind APIs. Open weights models give you the actual file. The weights are the model. Owning that file changes everything about deployment. 3 reasons this matters. Your data stays on your hardware. No per-token API costs at scale. The model runs anywhere you can run code. 3 real engineering advantages. Google has a track record here. The Transformer paper, Kubernetes, TensorFlow, foundational technology released openly. Gemma 4 fits that pattern. Open weights does not mean fully open source. Google shares the weights, not the training data. But for engineers running models on edge hardware, weight availability is what matters most. Open weights is the category. Next, who is in this category in 2026, and how do they compare? Open weights is the category. Now the candidates. Several real options exist in 2026, each with strengths. A quick survey before picking one. Gemma 4 from Google. 3 sizes: 4 billion, 12 billion, 27 billion. Open weights with permissive licensing, strong tooling ecosystem. Llama from Meta. A family of models in many sizes. The largest open weights community. Its license has some restrictions for very large companies. Mistral and Mistral. Efficient inference, strong performance per parameter. From Microsoft, small but capable. Qwen from Alibaba, with strong multilingual support. 5 real options, all open weights, all capable of running on edge hardware, each with its own strengths and trade-offs. 5 candidates, all credible. Next, why Gemma 4 fit one specific use case, a home lab agent. Now the personal part, why Gemma 4 fit one specific use case, a home lab AI agent. Real hardware, real tasks, real trade-offs. My home lab is a Linux machine running a few Docker containers, MinIO for personal object storage, MCP servers for home automation, a handful of other apps, running quietly. The agent has 3 jobs. Watch the apps and notice when something needs attention. Call other services or MCP servers to do things. Answer questions through a chat interface. Everything local on my hardware. Today the agent watches MinIO and answers chat queries via Llama. The capabilities I am still building include yard camera detection, triggering lights, and broader home automation. Honest about the gap. 4 reasons Gemma 4 fit. Multiple sizes for different needs. 3 weeks of stable operation on consumer hardware. Good enough quality for home lab tasks, not best in class. And weights I can ship without licensing surprises. I built the agent with Spring AI. Not because the home lab needs enterprise scale, but because Spring's patterns for security, observability, and audit logging save me from writing those myself. Gemma 4 is not perfect for every use case. Next, when to pick something else. Recap: real hardware, honest trade-offs, good enough wins. Gemma 4 fit my home lab. That does not mean it fits every use case. Honest engineering means knowing where it loses. Heavy reasoning still favors the big cloud models. complex math, multi-step planning, deep logical chains. Frontier cloud LLMs are simply further ahead on these tasks. Code generation is another gap. For complex code generation tasks, debugging, large refactors, novel algorithms, frontier proprietary models are still ahead on quality. When latency requirements get extreme, sub-10 millisecond at scale, purpose-built distilled models often beat general-purpose ones like Gemma 4. Optimization for one task wins over general capability. For high-stakes autonomous decisions, where reliability must be certified, open-weights models lack the vendor support and certification path that some regulated deployments require. Gemma 4 wins for many cases, not all of them. Knowing where it loses is engineering, not pessimism.